This is Michael Hilton for Lab 5. Okay, got a little chart here. It tells us the difference between an aromatic compound, a non-aromatic compound, and an anti-aromatic compound. So aromatic compounds, they're cyclic, and they also have alternating double bonds. At each carbon, they've got an unhybridized p orbital, double bond, a lone pair, negative charge, or a positive charge, or a radical. Okay, so as long as one of these things is on a carbon, it meets this rule. The cyclic compound has to be planar, basically 8 to 13 carbons, means it's non-planar. It's got to meet Huckel's rule. That's 4n plus 2 equals the number of electrons, and n has to equal 0 or a whole number. Okay. So for a non-aromatic compound, basically it violates these first 3 rules, and if it violates any one of those, we know that it's a non-aromatic compound. Anti-aromatic compounds, they follow all the rules except Huckel's rule. So if you have a structure like this, you're going to come out with a n equals basically half a number, and 1/2 that doesn't equal a whole number, so you can classify that as anti-aromatic. As far as the worksheet goes, I'm going to show you 21. Okay, here's the structure right here. Now it meets all the rules of an aromatic compound, but when we count up the electrons, so we've got 2, 4, 6, 8, and plug that into the formula, we find 6 divided by 4 equals 1.5. So this is anti-aromatic. And the last one, I just thought these were interesting, meets all the aromatic rules except the formula. So we're going to count up the electrons: 2, 4, 6, 8. And remember, we only count one thing on an atom, so we could either count this double bond or the lone pair. So 2, 4, 6, 8, same thing, comes out to 1.5. So this is anti-aromatic.